and I welcome you all to Scientific Study for You. I am Apuru Pathak, and in this video I am going to start the chapter The Basic Concepts of Chemistry. So let's get started. Until now we all know that chemistry is having a lot of theories, like the theories related to atomic structure, the theory related to combustion, and many others. Okay, the most interesting fact about these theories is that all these theories have been developed following the similar set of procedures. It means that if there is theory A, okay, and there is theory B, both the theories will be prepared by following the similar set of procedures. Okay, similar set of procedures. Okay, and this procedure is known as scientific method. This procedure is known as scientific method. Okay, scientific method. The general approach to research is known as scientific method, and the definition for scientific method will be it is an iterative process involving it is an iterative process involving observations and formulations of questions based on observations, careful design of experiments, and thoughtful analysis of results. Okay, now try to understand this thing. I will explain it with the help of example. Okay, now suppose I will show you how the theories has been made until now. Okay, now suppose there is a person A. Okay, there is a person A. He observed that a couple including a boy and girl, came into relationship. Okay, relationship. Don't take this example too personally, it is just for the sake of explanation. Okay, so a couple came into relationship. This person A observed that after some time they broke up one day. Okay, after that this person observed few more couples. They came into relationship. Okay, they came into relationship and one day they broke up. Right, one day they broke up. Then this person A, first he was here observing. First he was observing. Second, he made a hypothesis that whenever two people come in relationship, one day they break up, and the time in which they are going to break up, it can be different. He gave a hypothesis. Okay, and to support his hypothesis, he conducted series of experiments in which what he did, he observed 100 couples. Okay, 100 couples he observed. Okay, in his experiments. Okay, Okay, and after observing these experiments, he finally concluded in the form of theory. That whenever whenever a couple comes in relationship, finally they break up one day. Right, this was the theory, and the time span may be different. Okay, this was the theory which has been developed by person A. This hypothesis, the interesting fact about this hypothesis is that this may be correct, or may not be correct. Okay, or may not be correct. but theory is correct because it is backed by these experiments. Okay, all right. But again a person B comes in picture. Okay, this person got the Nobel Prize already because of this theory. His theory was proposed like globally accepted, and he got the Nobel Prize. But a person B came into picture, and he said that he has few exceptions who came into relationship, stayed together the whole life, and which was incorrect, which was not explained by the person A. So this will be considered as the drawback of the theory of person A. Okay, so this is having a place as well. Okay, so this is how a theory has been developed until now. Okay, and this approach is known as scientific method. Okay, so there are four main components of scientific method. The first is, as I said, observations. First is observations, means formulation of questions. Okay, formulation of questions. Okay, second is the hypothesis. Okay, third is the careful design of experiments. Okay, careful design of experiments, and fourth one is the theory. These are the main four components of scientific method. All right, this is so clear. Now the thing is, next topic is measurement. Okay, measurement. Now the thing is, since experiments are involved in chemistry is considered as an experimental science. Experimental science. Okay, now since chemistry is an experimental science, and in experimental science we will have to carry out different experiments, and to carry out same experiments multiple times we must be able to specify or describe the object completely on which we are working. For example, if we are having a spherical ball and we wanted to calculate its density, then we must be able to know its mass. Okay, we must know its radius, and with the help of radius we can be able to calculate its volume. Okay, then only we can calculate the overall density of this object, right? So these quantities, mass, volume, radius, density, which can be measured by us, are known as physical quantities. Okay, what they are known as? They are known as physical quantities. Okay, physical quantities. Okay, and physical quantities are like mass, length, time, volume, and so on. Okay, now how we measure things? Until now we understood that there are physical quantities which can be measured, but how we measure? Now suppose we are measuring mass of an body, of an object. Okay, and we are having a iron bar. Okay, and we said that this is the standard. This iron bar is the standard, which means that the mass of this iron bar will be 1 unit. Okay, now suppose if an object will be twice as heavy as this iron bar, can we say that that object is 2 unit? Can we say that? Yes, right. If any object is 3 times the mass of this iron bar, then we can say that that object is having 3 unit mass, right? And if some object is having half the mass of this iron bar, then we can say that that object is having half the mass of that iron bar, means 1/2 unit, right? Similarly, there is a iron bar which is placed in Paris, and it is considered as the standard mass, kilogram. Its mass is 1 kilogram. Okay, so which is standard, and it is 1 kilogram. Okay, so here it is the number, and kilogram is known as the unit. Okay, so any physical quantity can be described completely with the help of number and a unit. Alone a number cannot describe a physical quantity completely, and alone unit also cannot describe a physical quantity. Suppose if I ask you what is your mass, and you tell me my mass is 60. what it will mean. 60 what? 60 grams, 60 pound, 60 kilogram, what? It doesn't say clearly that what is the mass. If you just say 60, if you will say 60 kg, then we will say that okay, 60 kg, now we can understand your mass is 60 kg. Okay, that's why to fully describe a physical quantity, both the unit and number are important. Okay, we cannot ignore one of them. Okay, now the next is one physical quantity can be have multiple units. For example, mass is having units of kilograms, gram, okay, pound, and so on. Similarly, length is having units, meter, centimeter, millimeter, inch, foot, and many more. Okay, so this creates a problem. Now suppose if you are if you are Indian, you are working in an industry in India, and their calculations are done on the basis of kilogram mass, kilogram meter second. Okay, and now suppose you went to America, and in the industry of America the calculations are done on the basis of inch, like inch, foot, pounds, minutes, this way. Then if there are small calculations, you can convert one unit into another. That's not a big problem. But suppose if whole book is written in the different units, then it will be so inconvenient to convert all the units in all the pages of that books, right? So to solve this problem, to solve this conflict, scientists throughout the world globally came to an agreement and accepted a system of unit internationally known as SI unit. Okay, SI unit, SI system of unit. In French, this is known as system international D unit. Okay, so scientists concluded this as the internationally accepted unit, and according to the SI unit, there are seven fundamental units. Okay, fundamental units. Now the question comes that what is a fundamental unit, right? Now the question is what is a fundamental unit, right? Fundamental unit. What is a fundamental unit? Actually, the physical quantities, okay, physical quantities can be divided into two categories. One is the fundamental or basic quantities. Okay, basic quantities, and the other is derived quantities. Okay, fundamental quantities are the quantities which are independent of other quantities. They are unique. They don't need any other quantity to describe itself. Okay, these are the basic quantities. And the derived quantities are the quantities which can be derived with the help of fundamental quantities. It means that they are dependent on the fundamental quantities. Okay, so the units of the fundamental quantities are known as fundamental units. Okay, fundamental units. And the units of derived quantities are known as derived units. Example of fundamental quantities like mass, length, time, etc. Okay, and the examples of derived units are volume, density. As you can see, it can be calculated with the help of other quantities. Volume can be calculated with the help of length, right? Length into length is volume. Density can be calculated with the help of mass and the volume. So these are the derived quantities. So according to the international system, I mean the SI system of units, there are 7 fundamental units. Okay, fundamental units. There are 7 fundamental units. Okay, fundamental units. and they are, first is mass, right, mass, and its unit is kilogram, abbreviated as kg. Second is length, okay, and its unit is meter, abbreviated as m. Third is time, its unit is second, abbreviated as s. Fourth is electric current, its unit is ampere, abbreviated as A. Fifth is amount of substance, its unit is mole, which we will cover in the later topics. It can be abbreviated as mole, okay. Sixth is temperature, okay, it's having unit Kelvin, and it is abbreviated as K. And the last is luminous intensity, okay, intensity, its unit is candela, 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 and it is abbreviated as CD, okay. So these are the 7 fundamental quantities, okay. Now there is another problem arises from this fundamental quantities, is that more often we encounter calculations in chemistry where we need to measure either very small quantities or very large quantities. For example, a chemist describing the diameter of sodium atom as 0.0000000000172 meters. In this case, meter is too large to specify this length, right? Meter is too large. Similarly, an astronaut describes the average distance of Earth from Sun as 150,000,000,000,000 meters. Again, this meter is too small for this quantity. See, now the speed of light in vacuum, it is, we know from our early classes, 3,000,000,000 meter per second. Again, here meter is a very small quantity to specify this large number, right? So, and this is very inconvenient. Imagine a book in which all the quantities are written in this form, so big numbers, then it will be very difficult for the writer as well to write all these things in a page, and it will be difficult for you to read the book as well. To solve this issue, since we encounter more often such type of quantities which are either very small or too large, the SI system has been modified with the help of prefixes, okay. And these prefixes are, I am writing, okay, these prefixes are if 10, the number is 10, it is known as deca. If it is 100 or 10 to the power 2, it is known as hecto. If it is 1000, okay, or 10 to the power 3, it is known as kilo. If it is 60 or 10 to the power 6, it is known as mega. For 9 zeros or 10 to the power 9, it is known as giga, giga, okay. It is abbreviated, and the last one for 12 zeros, okay, or 10 to the power 12, it is known as tera. Deca is abbreviated as DA, hecto is abbreviated as H, Kilo is abbreviated as K, mega as M, giga as G, and tera as T. For examples, quantities, this will be decameter, DAM, okay, hectometer, HM, kilometers, KM, megameter, MM, capital M, okay, gigameter, GM, terameter, TM, okay, no problem. These were for the larger units, larger quantities, okay, larger quantities, okay. For smaller quantities, smaller quantities, these are like 0.1 or 10 to the power minus 1, it is known as deci, okay, abbreviated as D. For 0.01 or 10 to the power minus 2, it is centi, okay, abbreviated as C, small c, okay. For 0.001 or 10 to the power minus 3, it is milli, okay, small m. For 0.000001 or 10 to the power minus 6, it is micro, abbreviated as mu. It is a Greek alphabet mu, mu, okay. For 0.0000000001 or 10 to the power minus 9, it is nano, okay, and it is abbreviated as small n, nano, okay. For 0.000000000001 or 10 to the power minus 12, it is pico, abbreviated as small p, okay. For 0.00000000000001 or 10 to the power minus 15, this is femto, okay, abbreviated as small m. For example, in terms of meter, it will be decimeter, it will be centimeter, it will be millimeter, it will be micrometer, it will be nanometer, it will be picometer, it will be femtometer, okay. So the problem will be solved. Now the diameter of that sodium atom can be easily written in the form of picometer, right? It will be 172 picometer. It will be very easy, right? So that problem is solved. Now if you will notice here in this table, here all these values, 0.1 is written in the form of 10 to the power minus 1, here 1000 is written in the form of 10 to the power 3. Basically the numbers are expressed in the form of exponents, okay. Such form is known as scientific notation, our next topic, okay. Scientific notation, okay. As we previously discussed that we often encounter such quantities in chemistry which are either very small or too large. So these quantities can be more conveniently expressed in the form of scientific notation. In scientific notation, the quantities are expressed in the form of exponents of the form a into 10 to the power n, okay, a into 10 to the power n. In this way we express in scientific notation, where a is a number ranging from 1 to 9.9. Basically it cannot be 10, it will be 1.1, 1.2, from 1 basically from 1 to 9.9, okay. And n is a positive or negative integer, okay. N is a positive or negative integer, all right. So this was the scientific notation. We can express any number in the form of scientific notation in the form a into 10 to the power 1, okay. Let's see steps to write scientific notation, okay. Let's see steps to write in scientific notation, okay. in scientific notation. Okay, so the first case is case 1. The first case is case 1. If quantity is greater than or equal to 10. Okay, if quantity is greater than or equal to 10, then shift the decimal point to the left by n places such that we get a number ranging from 1 to 9.9. okay, basically between 1 and 10 we have to shift the decimal point to the left such that we get a number ranging from 1 to 9.9. okay, then multiply the result okay, multiply the result by 10 to the power n. okay, now let me explain it with the help of example. Don't worry, I will explain. For example, if we want to convert, suppose 83659, okay, in scientific notation, if you want to convert this, okay, then how we will do that? To scientific notation, how we will do that, right? So first write 83659. we all know that if a number is written in this form, it means that we can write it 83659.0, right? So current position of decimal point is here, and to change this to a number ranging from 1 to 9.9, we will have to shift the decimal point up to here, then it will be 8.3659, right? So we have to shift this decimal point up to here 1, 2, 3 and 4 places, right? 4 places. So here I will write shift the decimal point to left by 4 places, right? By 4 places, so that we get a number ranging from 1 to 9.9, right? We did it. So this will be 8.3659, okay, into, and we know that we have to multiply the result by 10 to the power n. Since we have shifted by 4 places to the left, it will be multiplied by 10 to the power 4. okay, why we have multiplied by 10 to the power 4? Because we have shifted decimal point to left by 4 places, right? No problem at all. This can also be understood as see carefully, the number was 83659, right? 83659. We can also understand it as we have to shift the decimal point up to 4 places, as you can see from here to here. So we will divide it by 1 by 1, 0, 1, 2, 3 and 4 0, 10,000. We will divide it by 10,000, right? To shift the decimal by 4 points in the left direction. Okay, we will divide it. So we are dividing by 10,000 to shift decimal to left by 4 places. right, to get a number ranging between 1 and 9.9. Since we have divided by 1000, compulsory we need to multiply it by 10,000 as well. Since we have divided it by 10,000, to cancel this 10,000 we need to compulsory multiply this by 10,000 as well, right? Compulsorily multiplying by 10,000 as well. Okay, so this will become 8.3659 into 10,000, right? And 10,000 can be written as 10 to the power 4. So the final result will be here I am writing final result will be 8.3656 into 10 to the power 4. All clear? No problem, right? So the next case is case 2. Case 2 is if quantity is less than 1. First case was if quantity is greater than or equal to 10. Now the second case is if quantity is less than 1. What we'll do in such case? Shift the decimal point, to right by n places, such that we get a number ranging from 1 to 9.9, and then multiply the result by 10 to the power minus n. Okay, in the previous case it was 10 to the power n, in this case it is 10 to the power minus n. All right, so let's see, let's understand this with the help of example. Now suppose we are we have 0.00532 and we want to convert it to the scientific notation. Then how we will do that? Scientific notation, right? Then how we will do this? We will again write this 0.00532. Now see, if we will shift the decimal point to 3 places to the right, then it will become 5.32, which is between 1 and 9.9. As you can see from here, 1 place, 2 place and 3 places. If we shift 3 places to the right, then we will get a number ranging between, how much? Ranging between 1 and 9.9, right? So we will do that, and it will become 5.32, and it will be multiplied by 10 to the power minus of the number of places shifted, that is 3, right? Why we multiplied by 10 to the power minus 3? Because we shifted decimal point to right by 3 places. That's why we have multiplied by 10 to the power minus 3. Okay, clear? No problem at all, right? It can also be understood as, okay, we had the number 0.00532, right? It can also be understood as, since we have to shift the decimal point by 3 places to the right, okay, we will have to multiply it by 1000, right? We will have to multiply it by 1000. Okay. So we will write here multiplying it by 1000 to get a number between 1 and 9.9. okay, since we have multiplied it by 1000, compulsorily we will have to divide it by 1000 as well, right? So again we will write compulsorily we will have to divide by 1000 as well. Okay, so this will become is equal to 5.32 into 1 by 1000, right? And 1 by 1000 can be written as how can be written as 10 to the power minus 3, right? So final result will be what? 5.32 into 10 to the power minus 3. Okay, 10 to the power minus 3. Clear? Right, now we will move to the next topic, which is calculations involving scientific notations. Calculations involving scientific notation. Okay, so the first case is addition and subtraction. Okay, first is addition and subtraction. Okay, addition and subtraction. Now suppose we have two quantities where x is a into 10 to the power n and y is b into 10 to the power n. Okay, then the summation of x plus y, okay, can be written as a into 10 to the power n plus b into 10 to the power n, where 10 to the power n will be common, so it will be, okay, a plus b into 10 to the power n, right? Similarly, if it will be minus, x minus y will be a minus b into 10 to the power n, no problem, right? For example, okay, for example, if x is 3 into 10 to the power 3, y is 2 into 10 to the power 3. Okay, here one thing is, remember, provided this addition or subtraction is possible, provided both x and y should be having same exponent. Okay, this addition or subtraction is possible only if both x and y is having same exponent, as you can see in this case 10 to the power n and 10 to the power n. If there will be different exponents, then this formula will not be valid. Okay, so I was giving the example, x plus y will be, in this case x plus y will be 3 plus 2 into 10 to the power 3 equal to 5 into 10 to the power 3, and x minus y will be 3 minus 2 into 10 to the power 3 is equal to 1 into 10 to the power 3. Okay, clear? Now the next is multiply and divide. Second number is multiply and divide. Okay, so if x is a into 10 to the power n1 and y is b into 10 to the power n2, then x into y will be a into 10 to the power n1 into b into 10 to the power n2. Okay, to 10 to the power n2. After that, we will take the numbers in one bracket, a into b, and the exponents in other 10 to the power n1 into 10 to the power n2. Now we have studied in class 6 or 7 that if x to the power a is multiplied by x to the power b, then the product will be x to the power a plus b, if you remember. So this will be a into b into 10 to the power n1 plus n2. Okay, so x multiplied by y will be a into b into 10 to the power n1 plus m2. All right, no problem. Okay, and for the divide purpose, if it will be x by y, it will be a by b, and similarly 10 to the power n1 by 10 to the power n2. We know that if x to the power a by x to the power b is there, then the product will be x to the power a minus b. Okay, so it will be a by b into 10 to the power n1 minus n2. So x by y will be a by b into 10 to the power n1 minus n2. Okay, all right. Okay, for example, if x is 3 into 10 to the power 6 and y is 2 into 10 to the power 3, then x into y will be 3 into 2 into 10 to the power 6 plus 3 equal to 6 into 10 to the power 9. For x by y, it will be 3 by 2 into 10 to the power 6 minus 3 is equal to 1.5 into 10 to the power 3. Got it? All right, it was simple as well. Now let's move to the next point. Okay, which is, let's move to the next point, which is power and root. Okay, power and root, third. Okay, power and root. Okay, so if x is a into 10 to the power n, and if we will do x to the power m, then whole will be having a into 10 to the power n to the power m, then it will be a to the power m into 10 to the power n to the power whole m. So x to the power m will be a to the power m into 10 to the power n into m. Okay, simple. Similarly, if there is root x, then it will be x to the power 1 by 2 equal to a to the power 1 by 2 into 10 to the power n by 2, right? Therefore root x will be root a multiplied by 10 to the power n by 2. Similarly, if there will be cube root, like cube root of x, it will be cube root of a into 10 to the power n by 3. Okay, simple. We will see the example of this. For example, if x is equal to 9 into 10 to the power 6, then x square will be 9 square into 10 to the power 2 into 6 equal to 81 into 10 to the power 12, right? Now for changing it into scientific notation, we will move the decimal point to the left, equal to 8.1 and 10 to the power 12, and we will multiply it by 10 to the power 1. That since we shifted the decimal point to the left, 10 to the power 1 will be multiplied, therefore it will be 8.1 into 10 to the power 13, right? Now if there will be root x, okay, root x, then it will be under root of 9, okay, under root of 9 into 10 to the power 6 by 2, which will be 3 into 10 to the power 3. Clear? So so that's it. It was all about today's topic. We have covered so many things, starting from the scientific method, then we moved to the measurement, SI units, and we solved few problems, like there was problem in measuring the small units and big units. Okay, After that we came to the scientific notation. We learned how to write scientific notation, okay, like writing in the form of exponents a into 10 to the power n. And after that we moved to like calculations involving the scientific notation, and we covered the addition, subtraction, multiplication, division, and powers and roots. So that's it for this video. Thanks for watching.